Joints is the topic of this screencast and may be found in Chapter 6 of your textbook. This screencast was designed to achieve the following objectives: describe the functional and structural classification of joints and give examples of each, describe the components of a synovial joint, and lastly, describe the types of synovial joints and provide examples. Joints are articulations of bones, or simply where bones meet. The functions of joints are to hold bones together and, in some cases, to allow for mobility. Not all joints allow movement. Joints may be classified functionally by the amount of movement that they allow, and structurally by the type of material that connect the bones at a joint. Functional classifications of joints include synarthrocies. These are immovable joints, such as the sutures of the skull. When I first started learning this material, I always thought of synarthrocies as it's a sin for those joints to move, and that helped me remember that synarthrocies were immovable joints. Amphiarthrocies are slightly movable joints, such as the joints of the vertebral column, which allow some flexing and some extension as you bend over or bend back or bend to the sides. Diarthrocies are freely movable joints. These are the joints that are found in the limbs, at least most of the joints of the limbs, such as your fingers, where the humerus articulates with the scapula of the shoulder. Joints may also be classified structurally by the type of material that connects bones of a joint. Fibrous joints contain collagen fibers. Cartilaginous joints contain cartilage. And synovial joints contain synovial fluid. At a fibrous joint, bones are united by fibrous tissue. An example of a fibrous joint would be the sutures of the skull. Here, the fibers are so short that they don't allow any movement to occur. Another type of fibrous joint would be a syndesmosis. Here, the fibers of the joint are a little longer, so they do allow for some movement to occur. An example of a syndesmosis would be the joint formed at the distal end of the tibia and fibula of the leg. At cartilaginous joints, bones are connected by cartilage. Examples would be the pubic symphysis, where the right and left pubic bones unite, and the intervertebral joints, where the intervertebral discs lie between adjacent vertebrae of the vertebral column. Synovial joints are the third and final structural classification of joints. Synovial joints contain a space between the bones which is filled with synovial fluid. All of the articulations or joints of the limbs are synovial joints. So the joint between the humerus and scapula of the shoulder, the joint between the radius and ulna of the forearm, and the joints between the carpals of the wrist are all synovial joints. This figure illustrates a typical synovial joint. I'm going to use it to discuss the various features of a synovial joint. This specific synovial joint is the articulation between the head of the humerus and the glenoid fossa of the scapula. Synovial joints contain a fibrous articular capsule. This capsule attaches to the surface of the bones. It helps reinforce the joint. The inner lining of the articular capsule is the synovial membrane. Ligaments are thick fibrous bands of tissue that extend from one bone to another in an articulation. Some ligaments form part of the joint capsule, others are located in the joint space. Articular cartilage covers the ends of the articulating bones. There they help provide for a low friction surface at the ends of the articulating bones, and they also help cushion the ends of the articulating bones. The joint cavity is filled with synovial fluid. The synovial fluid is produced by specialized synovial cells of the synovial membrane. The fluid helps lubricate the joints. Bursa are small, thin-walled fibrous sacs that contain synovial fluid. The bursa basically act as cushions, help cushioning one structure against another, such as cushioning skin and bone, or ligaments and bone, etc. Tendons are similar to ligaments in that they are composed of bands of fibrous connective tissue. Tendons, of course, connect skeletal muscles to bone. Tendons are often surrounded by tendon sheaths. Tendon sheaths are essentially elongated bursa, and they have the same function as bursa to protect, in this case, the tendon from damage, provide a cushion of protection. The previous illustration of a synovial joint was not from your book, but I thought it did such an excellent job of illustrating the features of a synovial joint that I thought it was appropriate to use it. This figure is from your book, and I'm going to point out some of the same structures that I pointed out in the previous figure. So here we have the articular capsule. The articular capsule is composed of a fibrous capsule which helps surround the joint and also connects the bones of the joint to one another, reinforcing the joint. The inner lining of the articular capsule is the synovial membrane. The synovial membrane produces synovial fluid, which helps Synovial joints are classified by the shape of their articulating surfaces and by the amount of movement that they allow to occur. A pivot joint is formed where you have one articulating surface which is round and it fits into a sleeve formed by the other articulating surface. An example would be where the ulna articulates with the radius. This is a uniaxial joint because it allows rotation around one axis. In a gliding joint, you have flat articulating surfaces and the bones slide past one another. Such is the case where the carpal bones articulate with one another. There is no rotation around an axis, therefore these are non-axial joints. A condyloid joint contains one egg-shaped articulating surface and the other surface forms a depression. This occurs where the metacarpals articulate with the proximal phalanges of most of the fingers. There is rotation around two axes, so this is a biaxial joint. A saddle joint occurs between the first metacarpal and the proximal metacarpal of the thumb. Here you have two saddle-shaped articulating surfaces. Like the condyloid joint, you have rotation around two axes, so the saddle joint is also a biaxial joint. At a hinge joint, you have this cylindrical surface formed by one bone, and then you have a matching concave surface provided by the other bone. A hinge joint is what exists between the ulna and the humerus, and if you really look at that joint, you can see that it's aptly named because the joint looks very much like a hinge. At a hinge joint, you have rotation around one axis, therefore a hinge joint is a uniaxial joint. The last joint is a ball and socket joint. Here you have a spherical head that fits into a spherical socket, and it resembles a ball and a socket, so it's aptly named as well. A ball and socket joint occurs where the humerus articulates with the scapula and also where the femur articulates with the acetabulum of the hip bones or the os coxae. Ball and socket joints allow rotation around three axes and therefore are referred to as multi-axial joints. We will not discuss movement of synovial joints and other joints in lecture. This material was covered in lab. So although this information is found in your textbook, you can omit it from the lecture portion of the course. To review, the objectives of this screencast were as follows: describe the functional and structural classification of joints and give examples of each, describe the components of a synovial joint, and lastly, describe the types of synovial joints and provide examples. The next screencast will cover inflammatory joint disorders.